Hello everyone, welcome back to our Engineering Graphics YouTube channel. Friends, in this session, we are going to solve a problem based on isometric projection, and the problem statement is the figure shows front view and top view of an object by first angle method of projection. Draw its isometric view taking origin O and give the overall dimensions. Now, the example in this problem, the front view and top view, these two views are given, and these views are drawn with the help of first angle method of projection. We know that when the problem is solved by using first angle method of projection, at that time the front view gives us length and height, and top view, in the top view we get length and width. So for this object, for isometric view, we required maximum length, maximum width and maximum height for this problem. And this length, width, height we can easily measure or find from front view and top view. Now here, in the top view, we get a length. So from origin O, from this corner to this corner is the total length. 65 plus 15 plus 15 plus 15. So I think it is 110 mm is the distance. 65 plus 30 plus 15, correct. 110 mm is the length. Height of this object, in the front view we get a height 40 plus 10, height is 50 mm, and width is again 50 mm. So from front view and top view we can find length, height and width. Now for isometric view we required a isometric box, and this box consists of three different planes. This is plane 1, this is plane 2, this is plane 3. Now here origin O, see the origin O. The origin O is given at the left bottom corner. So here is the position of that origin. So for this problem, this direction we can mark, this length we can mark along the x axis. This is x, this is y and this is z. These are the three different axes. So this front view, हा जो फ्रंट व्ह्यू आहे तो आपल्याला प्लेन 1 मध्ये मिळणार आहे. ऑब्झर्वर looking direction is x. When the observer looking from this direction, so plane 1 मध्ये आपल्याला ह्या शेपचा फ्रंट व्ह्यू मिळेल, and in the plane 3rd we get the top view. So with the help of front view and top view we can easily draw the isometric view for this problem. Now here, see the problem. From problem already we have find length, width and height. Now read the drawing carefully, understand the view, then we will see the solution for this problem. Now this profile we can give the name O1, 2, 3, 4, 5, 6, 7, 8, 9. Now this profile, its position is here. Observer position is here. So this O to 9 profile position is here, and this profile have 50 mm thickness. Then after that, on 5, 6, 7, 8 profile there is a circular hole, and this hole is throughout. Its depth is 50 mm. Now on the back side there is a rib or just triangular part. The thickness of that triangular part is 25 mm. हा जो पार्ट दिसतो आहे ट्रायंग्युलर शेपचा, its position is back side of this object and thickness is 25 mm. And this surface is the slant surface. You can see this slant surface position is here. This is a slant surface. Now see the solution for this problem. So for isometric view, first draw the isometric box, and for isometric box Take 30, 90, 30 degree angle. Draw the horizontal line. Mark origin O. Thirty, 90, 30. Take 30, 90, 30 degree angle and by using thin line, make the isometric box. So for this problem, this is the x-axis, this is z-axis and this is y-axis. Along x-axis आपण लेंथ मार्क करणार आहोत. Z-axis ला हाईट आपल्याला मार्क करायची आहे and along y-axis we are going to mark a width. The length of this object is 110 mm. So mark 110 mm distance and width 50 mm. Width 50 mm and height is again 50 mm. And height is 50. Now with the help of roller, complete the box. Adjust a ruler along y direction and complete the plane third. Now see, the box is ready. So this is the length 110 mm, height 50 mm and width 50 mm. So this box consists of 3 x-axis, 3 y-axis and 3 z-axis. This line is going to the x-axis. Similarly, this line is going to the x-axis and this line is also going to the x-axis. Z-axis, z-axis, z. Y, y, y. Now, see the problem and we make or we draw the O2 profile first. O2 1 edge is 110 mm. The origin O is here. So we will draw the baseline first. Then from this 1 to 2 height is 40 plus 10, 50 mm. Then 2 to 3 is 15 mm. Along the x direction, mark 15 mm distance. Now you can see here, this line is going to the view is like that. This is x, this is z. So all these lines 1, 2, 3, 4, all these lines are parallel to the x-axis. They have x-axis the parallel line upon along the x forward and reverse draw करणार आहोत. Now see that this is point number 3. Now 3 to 4 distance is this line. 3 to 4 line is going to the reverse z. So 3 to 4 line is along the reverse z axis. So along the z axis mark 40 mm distance. 40 mm. Then 4 to 5 again it is 15 mm. This distance is along the x axis. Then after that, this 6, 5 and 7, 8 line, they are inclined lines, and these lines are called as a non-isometric lines. These lines we can't draw directly, but we know that the center of that 7 6 line is given, it is 47.5. so along the x-axis at a height 50 mm, we will mark 47.5 distance. This is 47.5 distance, and along this point we will mark 17.5 distance on the both side. So measure the 17.5 mm distance in the compass. 17.5 mm distance, and then mark this 17.5 mm distance on the both side of that marking point. Now this edge, its distance is 35 mm. Now O to 9 height is 10 mm. Along the z-axis we will mark 10 mm height, and from that again 9 to 8 distance is 15 mm. 9 to 8 distance is given, it is 15 mm. So mark again 15 mm distance, and you can see this is point number 8, this point number is 5. So we can directly join point 7 and 8. We can directly join 7 and 8 and 6 and 5. This is point number 6, this is point number 5. Join these two end points by using a straight line. So we have completed the O to 9 profile. Now this profile have 50 mm thickness. This profile have 50 mm thickness. Now we add the thickness. This line is going to the width side. Similarly, this edge going to the width side. Similarly, this 35 mm line have the 50 mm width. This is 50 mm width. Similarly, this total distance is 50. So this 9 to 8 edge have 25 mm thickness, and again from 25 10 mm z axis line, which is formed from 25 mm from front surface. Now here we will draw a 25 mm straight line along the width side from 9 and 8. We will mark 25 mm distance. This is 25 mm. This is also 25 mm. This is a flat surface. This flat surface position is here. Now from this point there is again 10 mm vertical rise, a vertical line. So from this point we will draw the vertical 10 mm line. Now here. Now here friends, again this line number, this is 10 number point. This 3 to 10 line is a non-isometric line. Angle is not given, but directly we can join point number 10 and 3. So here we can find this end point first. This is the end point. Now directly you can join this end point and this end point by using a thin line first. This inclined triangular shape parts have 25 mm thickness. So along the y direction we add 25 mm thickness. This distance is 25 mm. Again we can join this point and this corner point by using a non-isometric line. Join these 2 points by using thin line. Now here, this triangular part, but this triangular part is merged with this, this conical shape part or nozzle shape part. Now here, from this point, this edge 40 mm edge is vertical. So we will draw this edge first. We are drawing this 3 to 4 edge, which is its position is here. Using thin line, join it and adjust a ruler along y direction and join it. Now this one. Now after that, again this is a slant line or non-isometric line. So same line is visible. It's not here. Its position of this line, its position is at the 25 mm back side. So we are adjusting this. Just wait, we'll first complete this profile. This profile is visible. This profile is visible. Now this line is also visible. So make it dark. Now this is a slant surface. This surface, before that, draw the back side. This same edge is appeared on the back side also. So make it dark. From this point. Now this is the slant surface we have drawn. 7, 8 edge, its position is here. Same edge is appeared on the back side. Now after that, from that, we can directly join this line and these 2 points, these 2 end points, we can join it. This edge is also visible. Now see that this triangular part, it is merged with that vertical conical part or nozzle shape part. Okay, this is a solution for this problem. Now the circular hole is remaining here. Now for circular hole position is at the center point of that 6 7, and from base its height is 20 plus 10 30. Now here along the z axis, first we will mark a center of that circle and its position from base is 30 mm. is the center point. This is the center point for this circle. Now we will draw a rhombus here. Diameter of that circle is given. Diameter is 30 mm. So we require 30 by 30 rhombus. Now take 15 mm radius in the compass and take 15 mm radius, and along the center line mark 15 distance on the left hand side, right hand side above the reference line, below the reference line. Here, these are the points of that rhombus. Now by using roller, make the rhombus here. Now here, in this rhombus, we can draw this circular hole, and this hole is throughout. The circular hole looks like an ellipse shape in the isometric view. So for a circular hole, join obtuse angle and opposite side midpoints of that rhombus. So these two are the obtuse angle. Join this obtuse angle and opposite side mid. Now we got the four center here. Now join all these four center by using rounder. Now here, take this C1 center, C2 center, C4 center and C1, C2, C3 and C4 center. Now take this C1 center and join these two arc, two points. Now take this C2 center, join it. Take this C4, C3 center, join it. Take this C4 center and this radius, join it. Now here you can see, this is a solution for this problem. We have drawn circular hole, this triangular shape reef and this O29 profile. Now give the dimension, give the overall dimensions for this object. This is the width, give the dimension above the dimension line. So this is 50 mm width, $110, $50 35 15 15 circular hole, $530. Now see the complete solution for this problem. This hole is throughout, so this dotted line indicates the circular hole position. Try to solve this problem, friends. Thank you for watching this video. If you found this video helpful, please like, share and subscribe our channel. We will meet again in the next lecture. Thank you. Bye. Happy learning.